Hi there. I'm Vincent from VXT, based in Finland. We are a software company specializing in machine learning and natural language processing. First of all, big thanks to AEC Hackathon and, of course, Damon, who's invited me personally to give a talk in this very exciting online format of this event. As an alumni of AEC Hackathon, we're very proud and very happy to be able to address you as an audience here, be whether you're hacking or whether you're in the industry as partners to this hackathon. So today I'd like to give you 3 ways to forecast the future of artificial intelligence in the AEC industry. Artificial intelligence is a very hot topic, and AEC has been, according to many media sources, lagging behind on innovation adoption. And I hope that this talk today could give you some concrete ways that you can take away and that you can use to drive your strategy in innovation and digitalization in your own applications, to get ahead of the curve and to reap the full benefits of digitalization in your own workflow in practice. So let's get to the first way, is to understand very from fundamental principles how AI works. And a lot of people are not very familiar with the AI scene, not only because they are not technically inclined, but because the media makes it especially difficult for people to get their heads around this whole AI landscape. And I thought to touch on very simply a rational view of all that you need to know by providing you with a few AI concepts that you would have come across in your day-to-day. You would have heard of artificial intelligence countless times, I'm sure. And AI is now very, very openly used as a term, which may or may not include applications that utilize machine learning approaches. And machine learning is, for many AI purists, considered the crux of AI applications. You'll hear machine learning being described as supervised or unsupervised, reinforcement learning, semi-supervised learning, etc., etc. You don't have to worry about those classifications. Perhaps all you need to know is machine learning is very closely related to statistical techniques where a lot of data is used and pattern recognition is applied to induce the reasoning logic behind a lot of processes and inputs and outputs, as opposed to starting from the rules. And I talk about that in a little bit more detail. Underneath machine learning, you would have also heard deep learning or convolutional neural networks, or whatever other configurations of neural networks that could be used to improve aspects of the learning and the logical pattern recognition. And those are all described and clumped together as one big word called deep learning. Then you get other hot topics like signal processing here at the bottom, computer vision, image processing, and incidentally, natural language processing, which is what our company VXT specializes in. It's also one of probably the oldest forms of AI that you would have heard about, starting from the 50s and the 60s already, utilizing natural language. So I'd like to talk a little bit more about machine learning and natural language processing to give you a better idea of the fundamentals of AI. As briefly mentioned earlier, in traditional computing, we think of input and we think of outputs and we think of the process in between. And usually in traditional computing, you have some input data or parameters into a process which is predefined. And this process is what you call the program or algorithms. These are predefined rules and sets of commands to be executed. And then the value is in the outputs. Now with artificial intelligence or machine learning applications, often you start out with the data and you start out with the results. And you want to know what is the logic that connects the two of them. If I have this input and I have this output, how do I replicate that? And you use machine learning to be able to build up your model. And this is often considered to be the crux of a machine learning algorithm, is the model that it induces from the training data. And likewise, when the model is constructed, you're able to use that model in traditional computing. So in a very simple application, you might say, I have a lot of pictures of cats and I'd like to label them, or pictures of cats and dogs and I'd like to label them. And you provide them with label data. The algorithm is then able to figure out over a variety of techniques what is the logic. And that model could then be used in a traditional computing application to label cats and dogs. In terms of natural language processing, the same way could be done with labeled data where human understanding of natural language texts are required. And that allows you to do a lot with new cases of natural language texts. And machine learning is able to utilize new data as well as old data to give you recommendations or actions that would have required human reasoning in the first place. So I'd like to give you some examples of natural language processing in AEC. It might not be so self-evident why natural language processing is so important in traditional industries. And the one reason is that we often don't have a lot of structured data in AEC. Although we have a lot of text, we have text galore in all sorts of databases and communications. And that gives us actually a very interesting foothold and platform on which to develop the applications, where one can start out from the very simplest form of text applications that you can imagine, which exists already in many different contexts in AEC, but then also building up in level of abstraction to very, very advanced use cases. One of them could be something as simple as unstructured data analysis applied in something like risk assessment. If you have databases worth of documentation, contracts, claims, documents, change requests, rework documentation, one can train machine learning algorithm to be able to flag risks and detect incidents, for instance, and issues. One can also start to link qualitative indicators, not only in terms of risk value or risk quantities, probabilities and impact, but also some aspects of why a risk might be a risk or why a case might be a risk. What are the sentiments that are related to that in existing documentation? And of course, if in your data set there has been lots of recommended actions, machine learning applications are then trained to make recommendations just as well. And to be able to, from a set of unstructured text, be able to extract text in different kinds of categories. And this brings us to something which are more in the data mining and analytics side, where we look specifically at data extraction. So how to classify data in all its different forms. How do we look at named entities? How do we look at semantic, fuzzy, nuanced type of text where lots of different ways of natural language is used to describe very similar processes? When one talk about prefab, precast, factory automation, or one talks about in situ concrete trucks, these are all different clusters of related topics which are muddled up in text, which makes text very difficult to analyze. And this is the crux of the ontological and interoperability problem, where now huge movements like IFC standards and COBE standards in the operation space are trying to, with a top-down approach, have data in a native format that is usable in that way. Although we all know there's still a lot to be desired, and we need to look at ways to bypass the ontological techniques as well. So we do a lot of work in this space, in aggregating and summarizing unstructured text, and of course some level of trend detection over time, whether it's through time dimensions or any other dimensions that may be interesting, such as monetary dimensions or then otherwise socio-political dimensions, sustainability dimensions, and so on. So we do a lot of work with government as well that utilizes this type of techniques to find trends in the AEC industry or otherwise, and to then produce insights. And I thought to provide you with just one example of what one can do with risk flagging, or then what we've mentioned earlier, text analytics and aggregation, text-based reasoning could then be applied in very simple ways. Here you see a bunch of past cases that could be read and used as training data. New cases could be presented as queries, and therefore insights could be done or retrieved to be used in assisting new cases or new decisions. And this kind of a workflow is very powerful in all sorts of applications. One example could come to mind as an operations and maintenance workflow where you have a linear, and you see that a lot of construction occurring in Europe are becoming very, very automated. So not ad hoc decision making, but a lot of repetitive processes that goes from one location to the next. And then you see in the construction processes that one starts with work planning, work ordering, some type of execution, completion, and maybe some level of KPI or reporting. And the knowledge that is accumulated over time in these cycles are often not fully capitalized. And machine learning allows us to be able to capture the realities or the situation of work on site or during operations and maintenance post-construction, and enable this kind of knowledge and insights to be inputted in the work planning processes. So what is our takeaway? I think very simply put, we want to see machine learning not for what the media wants to see it. So AI is not often sexy as the media would portray it. And maybe this is not something very obvious, but machine learning as an AI application is often just a very small part of a solution stack, even in the tech stack. So, and then the technology forms maybe a small part, albeit often an integral part, but a very small part of the full solution involving human processes, as well as other types of strategic or operational decisions that might be led by executive. So we see that these applications of AI and artificial intelligence is not so foreign compared to what you yourself have been in touch with. So applications like search have huge amounts of machine learning involved. Contextual extraction and data linking may very likely have machine learning involved in them. Clustering and reasoning type of applications where large amounts of data is used and inputted for insights to be summarized often have existing machine learning involved in them as well. So I hope that the first way is to cut through the noise of tech buzzwords and hype in the media, and to be able to view some AI capabilities from first principles and with the basis of your experiments. So we typically like to tell our partners and clients, when AI cannot be explained in 2 minutes or less, the application is often obscure and one might not be able to see real value in them. The second way to predict the future of AI in AEC is to understand the value of data in AEC. And we ask often the question, is data the new oil for AEC? And I'd like to show you what the media likes to paint a picture of oil and data as an analogy. So in 2017, The Economist says the world's most valuable resource is no longer oil, but data. And in 2018, Forbes says, here's why data is not the new oil. Again, in 2019, Wired says, no, data is not the new oil. And Forbes, again in 2019, contradicting themselves in 2018, claims that data is the new oil, and that's a good thing. So what's the deal? Okay, so lots could be said about oil as an analogy to data, but let's not get into that discussion. I think we need to ask ourselves, what is the money implications of data in general? Data is the lifeblood of AI, and it's very easy for media to use it as a hot topic in generating hype about what data should mean to large companies. So let's break it down and let's look at the largest companies in the world between 2001 and 2016. This is done through market capitalization, and you'll see that in 2001, largest companies in the world, the top 5 anyways, General Electric, Exxon, Citi, Walmart, they are not really digital companies, while in 2016, all 5 of the largest companies in the world are digital companies. And this is an astounding picture that you see. Apple, Alphabet from Google, Microsoft remains there, Amazon, Facebook. This creates a huge impression. So much so that, of course, the same with many OECD countries, as Finland would also paint their economic restructuring vision as well as history. So you see that from the 1950s to 2030, Finland has this particular view, going from agriculture to industry, which still exists in the economy heavily, but services is seen to reduce over time, and as if data and AI would take the place of services in between the period of 2010 and 2030. We see this, of course, in many countries around the world, in many very developed countries. So despite that, we need to think about data in terms of value as well. And this might provide you a different view of data and value. So according to IEEE, they've done heavy research into the amount of data that exists and the value that they represent. This is just a diagrammatic view of what that is. But the point is that here on the left-hand side, the amount in exabytes of data, now there are a lot more digital data than the analog data in gray, both of which are still expanding. But there is a lot of difference in, if we consider the dollar value of that. Now, currently, the dollar value is still actually very much captured by analog data, although the digital data and the value captured by digital data is increasing and will probably one day overtake that. But we are still a ways off, in fact, in contrary to what the media would like to paint. We see articles like this: digital ad trend or digital ad revenue in the US surpassing 100 billion for the first time in 2018. And indeed, despite that, Amazon, Facebook, and Google has 70% of market share in advertising. We still actually don't know whether paper, brick and mortar type of magazines like National Geographic and Times, whether they profit more from their paper hard copy advertising, or do they actually profit more from their digital advertising? It's really hard to say at the moment. You get other examples like this, which is a little bit more dystopian and perhaps comical, that musicians are now often earning more from their t-shirt sales than their music. And just to illustrate to you, a musician or a band on Spotify earns about 0.3 cents per stream. And if they sell a t-shirt for $15, that equates to around 5,000 streams on Spotify. They need 5,000 streams to match the revenue that they can get from simply one t-shirt. And this band here, While She Sleeps, really tried to mock this and became very famous in the media about their t-shirt sales. That's basically takes the mock out of this particular phenomenon. So what does this mean for a industry like AEC? So we are a little bit behind in the curve, which gives us some benefits of foresight when we look at other cases. So one prediction we can make now is that data and code will become plenty and cheap. That is a good thing as well as a bad thing when things become commoditized, when innovations become commoditized. And you can go into detail about what that means to your organization or what that means to your workflows. Secondly, some traditional offerings may become digital and automated. We see that in advertising, of course, to a large extent, tourism and travel, media business, but we already see some signs of that in the AEC industry, specifically in consulting, where you see most of consulting activities conducted digitally. CAD is the ubiquitous or the de facto way of doing drawings and design. Simulations are done in computers. And that might mean that tech players will start to gain market share in AEC, and ever more so. So we might only be in the very beginning of our innovation curve. So you see giants in the tech space, Autodesk, Nemetschek in Europe, for instance, Trimble or Tekla, big name here in Finland, that they have a huge market share now in the AEC industry, but there is a long tail of huge opportunities where the market is up for grabs. So with that, we can lead our discussion now to the third way of predicting AEC, future of AEC future of AI in AEC, excuse me, and that is through innovation. That is through where the innovation ecosystem is going, and whether organizations are innovating and how they innovate, and whether they're doing it fruitfully. So the question is how to innovate fruitfully. Now, the general view of the innovation adoption behavior could be captured quite well in this very famous diagram of differences between innovators and early adopters. And these are generally the visionaries that might utilize innovation and get an early start. Then there's a whole lot, the most are early majority and late majority, which represents, I think, the bulk of the profiles in the AEC industry who wants proven solutions. There are lots of benefits to that. So in the early adopters and innovators, they typically have a lot of trial and error and very high rates of failure. Whereas early majority and late majority can innovate through combinatorial innovations, where they take existing tools and repurpose them and get huge amounts of value from those. But then you get also the skeptics. And it's not to say that the skeptics cannot run a perfectly profitable business in AEC, but the difference is here on the market share side. The capturing of market share in those avenues rises exponentially, where it comes to an inflection point and then flattens out, which means that there is a huge advantage of innovators and early adopters to get the first mover advantage in markets. So looking at the laggers and traditional industries, there's a lot of failure that is described as creative destruction. And that implies that a lot of traditional industries and companies, they fall victim to digital destruction. And there are two main reasons why that's the case that might give a red flag. One is complacency, so waiting too long and acting too late. And that goes hand in hand with what we described just earlier about companies lagging behind or maybe are too skeptical. But I think a more important or maybe more relevant, pertinent discussion to have now in this context is the lack of focus. So companies might already be aware of the importance of innovation, but how do we go about innovating? Lots of companies fall flat in that, and I think we'd like to have a few words about that. First of all, instead of diversifying, large companies might be acquiring through mergers and acquisition tech companies to integrate into their workflow. But instead of diversifying, what happens might be what we call diversification, where the acquisition is not fully aligned with their business or with their value proposition in the core. And that makes them actually, that creates dilution of their capacity to deliver value offerings to their clients. And that creates actually barriers to reaping value from innovation. This does not only apply, the lack of focus, does not only apply to large companies, but also small companies when they are partnering with tech experts. And this is what we call a partner mismatch. So this could be very, very easily described to the silo between industry and so-called digital or tech experts. So finding the right tech partner is very difficult due to this type of fragmentation. What we want to do is to create a more sustainable innovation ecosystem where tech experts and industry could be able to be easily matched with one another, and to be able to find one another and see the value of technical, let's say, skills and tools and competencies in the value context of AEC industries, and of course vice versa. So in addition to the core technical work that we do at VXT, we're also quite active in this space. So purposing data mining and machine learning technologies in improving innovation ecosystems, helping matchmaking and accelerating the innovation cycle. And we do this by mining huge data warehouses in large companies. We are often involved in what they call startup programs, corporate programs, where large companies are innovating with startups and having to be able to, well, of course, profile them and shortlist them and so on. So we use data mining to mine large data warehouses in governments and or large corporations. We also do a lot of website crawling and scraping. We aggregate all the data, and we are able to integrate and use machine learning to analyze them and profile them. And not only tech companies, but also in the same breath, researchers and people. So through that, we can reveal links and relationships, which are very useful in creating matchmaking applications for large organizations to use. So our partners and clients share a vision with us of a connected innovation ecosystem, not just between tech experts and industry as a one-to-one, but also involving investors. So whether it's venture capital or otherwise, or institutional or corporate investors, but then also the university research institutions and so on, where a lot of the startups might come from. So we basically help hubs and matchmakers help people innovate. And I'd like to touch on a few whom we are in close collaboration with. We've been discussing and innovating with BloxHub for some time. So BloxHub is based in Denmark. They are the leader in partner and matchmaking in the Danish ecosystem. So I'd encourage you to contact them. Incidentally, they are also making a presentation in this AEC hackathon, so be sure not to miss them. Kira Hub is the AEC innovation hub in Finland, also in close collaboration with BloxHub together. And we have been partnering with Kira Hub also for some time. We have been doing a lot of work also with Business Finland, which is a governmental organization here in Finland. They are the official funder of research and innovation and technical developments here in Finland. So I encourage you to contact all of them if you're interested to come to Europe, understand and partner up with innovators in the Nordic, in particular, Nordic innovation ecosystem. We are very pro-European. We have a very pro-European mindset. And that's not because, one might think that Europe has maybe missed the boat on digital innovations in the consumer market. But we do see still large amounts of contributions from European companies in the industrial side. So B2C, maybe we have we see more contributions from the US market and the Chinese market, but in Europe, IoT, smart cities, sustainable innovations, these are still very, very European-led kind of activities. Just to summarize today, we talk about predicting the future of AI in the AEC. I gave you an idea of how AI works, and we talk about a few different ways of understanding the value of data that I hope you can take with you and revisit a lot of the things you may know that you know, and a lot of things you might not have known that you knew. And I hope that you can take these topics with you and apply them in your day-to-day, and in particular to innovate also then fruitfully. So instead of just predicting the future of AI in AEC, I would like to encourage you to take part in creating the future of AI in AEC, not as a bystander, but of course as a participant, as you all are. So forget the tech hype, focus on engineering based on your experiences. take effort to understand and explore what data or technology really is worth to you. It might be that data is not worth anything to you. It requires exploration and understanding and testing to fully understand the value of data, instead of giving in to the hype that the media usually portrays. And of course, with these two, collaborate systematically with tech partners. Take time to understand the nature of technical collaboration, the roadmaps, and learn from those who have been piloting and taking pilots to production, and maybe even taking production software to commercialization. There has been great success stories in that scene. So with that, I'd like to close up. I'd like to open up, avail myself to your contact. So VXT is an enterprise partner in textual analytics and natural language processing. And my name is Vincent. Please feel free to contact me for any questions you might have, any comments, criticism about the talk that I have. So we are quite active in many sectors aside from AEC. So feel free to share your thoughts. We'd love to hear from you. We'd love to learn from you. So with that, I'll close up and wish you all the very best, and happy hacking and happy innovating. Cheers.